Now here's some new vocabulary. Apothem is this word right here. Apothem. Apothem is how you say it. It's a pretty cool word. And it is the distance from the center of any regular polygon to the side. It's always perpendicular. So it's not your diagonal length here. It's your perpendicular from the center of any regular polygon to the side. So you could have a triangle, a regular triangle, and your apothem would be from the center out, perpendicular to one of the sides. So apothem, make sure you know how to pronounce it. So you can use this to find the area of any regular polygon. So if you look at this pentagon here, the area is the number of sides, n, times, you've got this triangle right in here. You've got, in this case, 5 of these triangles. So you would go 1/2 base times height, where your side is your side length. This is your S. And A is your apothem, which is your height. And in this case, we'd have 5 of these. You'd have 5 times half times your side length times your apothem. But you could use this for any polygon. If you had a hexagon, you would have 6 sides, so you'd have 6 triangles. They were all 1/2 base times height. So, but if you look at this formula, you can pull out portions of it. So here's, I don't like that color. If you look at this formula here for the area, and you pull out n times s. Well, n times s is the number of sides, like in my case here, it's 5 times s. So n times s is simply the perimeter. So if you pull out your n and your s, you're left with perimeter times 1/2 times a. So if you rearrange that, it's a nice, easy way to remember it. The area of any regular shape is 1/2 the perimeter times its apothem. So will you make sure you have pictures of a regular pentagon, or you could even draw a hexagon if you'd like. Let's see if I have one here, yeah. Draw a hexagon, make sure it's regular, and draw an example of your apothem. So you have to find the center of the shape, and it goes straight out perpendicular. And then make sure you have this formula. This is theorem 11.4, along with this in your notes. Next up, we have area of an equilateral triangle. So pulling from our trig, we know in an equilateral triangle, all of our angles are 60 degrees. So we know our sides are in the ratio of 1 to 2 to radical 3. Well, if we want to simplify this, I don't want this to be 1 because I don't want my whole base to be 2. So I'm going to make this 1/2. So I'm going to make this divided by 2, and I'm going to make this divided by 2. So they're still in the same ratio. But now I want to throw in a variable because I don't know. This isn't half exactly. They're just in that ratio. So we're going to let this be half x. This is just going to be x, 1x, because 2 over 2. And this is radical 3 over 2x. So now, let's use that to come up with area is always 1/2 base times height. So you have your 1/2. Our base, half x, and half x here is x. And our height is radical 3 over 2x. Once again, let's rearrange that and simplify it a bit. Let's pull out our 2 fractions. I've got a 1/2 here and a divided by 2 here, which is the same as 1/2, so I could rearrange that and pull it out as 1/4. I can put my radical 3 right there. Just pull it out, and then I've got x times x is x squared. So the area of any equilateral triangle, draw a little equilateral triangle there, is 1/4 times radical 3 times x squared, where x is your side length. So what's nice is you don't even need to know your height anymore. All you need to know is this side length here. So if my side length here was 5, my area would simply be 1/4 times radical 3. You could write this as radical 3 over 4 if you'd like, times 25. Type that into your calculator. See what you get. Make sure you have all of this in your notes, along with a picture and an example. So basically the whole board.